Tom Copeland is he's the chair of the robotics and OPC working groups for the MTConnect Institute Standards Committee. He's also the CTO at Track Machine Tools, a builder out of California. He's been participating in MTConnect for, I would say, what, about the last 5 years or so, and has been very useful and very active in trying to get the pieces of the MTConnect model and standard that are already pretty well established for CNC machines expanded into robotics and more general automation. So he's somewhat unique in that he has both a shop background and a little bit of programming experience, and also does lots of business development work as well. And coming from a medium-sized business, he's also in a unique position to kind of speak from that perspective to prospective users for MTConnect and of the various technologies that we've seen here. So he kind of fits a couple different buckets. He's both an end user and a machine builder and a system integrator. I'm excited to see what he has for us today regarding digital twin. This is an update to work that's been in progress for at least the last 18 months and continues to have new pieces of hardware and new pieces of software to connect the system components. So thanks, Tom, for presenting today. For those of you who missed some of the morning sessions, everything will be recorded and posted. I don't have an exact spot for where that's going to be yet, but I'll send out messages to the folks that were here, as well as to everybody on the standards committee, so that you can find this material again. Tom, with that, I'll turn it over to you.
Okay, Russ gave me a pretty good introduction. But fundamentally, what I've done for Track, I've been there for over 43 years now, currently kind of segueing my way into retirement. But I moved the company with technology. So you can imagine during that 40 some odd years, the range of technology that we've had to go through, as a company, as a sales organization, and actually presenting that technology to all of our customers. So that's why I've been there so long. This particular topic is digital twins for small, medium shops. I did a similar presentation at the GE in-person meeting earlier this year. So this is a different perspective. I finished all the robot stuff, so now it's easy to talk about something when you've gone the full cycle. So some of this is a little bit repeat, but other things are new. So what are digital twins? Digital twins to share your vision. Digital twins to get consensus. Digital twins to develop new products or processes. Digital twins to validate and implement ongoing improvements. And finally, data-driven manufacturing. What are digital twins? I just refer to the Wikipedia definition. The only thing I want to kind of caveat, digital twin can be hardware or software. I'm going to start at the end and then work backwards, so to speak. This is my digital twin I did before anything existed. And it was for me to kind of figure out how to do a different process using automation. So this particular platform is a Siemens Run My Virtual Machine product. And so I created a digital twin using engineering drawings for the machine. I had to modify some of the drawings from the robot company, and basically went through the process of, convincing myself first that this was a doable project. Today, this is basically done. So this is what it looks like in real life, which actually came very, very close to my digital twin that I did almost 2 years ago. Doing robots was a little bit challenging, and so I needed a way to kind of convince myself first that I could basically do multi-side machining, kind of the front, the back, and one side, and use the robot to flip the part and put it in the right fixture. So again, this is a digital twin. None of this existed prior to committing, resources to do this work. This is what it looks like today. we're taking the completed part out and putting it in the part management system, which is a simple grid plate. We're blowing the chips off the third operation twice. We're going to pick up the second op, put it in the third op while dump. Yep, that's the third operation. Same thing with blow the chips away. Then the first op to the second op while dumping the coolant out, the cavity there. Now the robot will actually blast the device again. Then I'll get a new blank part off the grid plate. Okay, so that's where we are. I was all done. First, usually things start off with a problem to solve. Someone needs to create some kind of vision for what they think the solution may be. Then we got to go out and get consensus with analysis to help justify spending money and time to do that kind of work. Then I needed engineering to help with a lot of the mechanical subjects, the PLC subjects, so it needed their resources to help. Then we had to develop the actual application with the fixtures, the grippers, and the part management system. And then I had to do the system integration, put it all together, make it work, and then finally get some results. And today, we'll spend some time talking about data-driven manufacturing, given I have real data now. So the problem was this. We were running this part on 3 machines, 2 lathes in the middle, front side, back side, and one of the side operations. And the mill was doing the milling, and obviously the lathe was doing the turning. I had one guy running this part. It's a pretty mature part, so it was a good candidate for automation. The vision. So this is kind of what I pitched. How about creating an automation cell with a robot? And so this was my original video that I did from the Siemens digital twin platform that demonstrated the machining process and the robot process all combined into one thing. And so this kind of did the trick to get people to understand another way to do this. This machining process wasn't that hard, but basically keep in mind we're moving from a turning process to a milling process. And that took a little bit of convincing, but by having a digital twin of the CNC control, plus being able to virtualize the machining process, just made it easy for everybody to understand. This is a little bit hard. It was hard to explain, turning to milling and then multiple operations. So this is how I pitched, moving the part from fixture to fixture using a robot. Consensus and analysis. I deal with all upper management, and I also deal with the people down on the floor. So getting consensus with a digital twin, I have to say, made my life really, really easy. I was prepared to spend months and months and months talking with management about doing it another way. And I was surprised by our shop manager. He saw this and immediately he said, yeah, this is what I want to do. And in fact, he had all the cutting tools and things I needed. that were kind of special to moving it from a lathe to mill in my office, like within a couple of days. So, and keep in mind, this has been my biggest job most of my career, is getting consensus and moving projects forward. And so don't underestimate how much time this will take. But the digital twin just made that process so much easier. Engineering had to go through the normal CAD process of making a layout, and then we exported the STLs or step files. I built all the digital twins myself, and then I used those that platform to keep everybody up to date as things moved, through the process. The application, this is a digital twin platform. So on the 3D side, you can have the visualization, you can simulate cutting, robot motion. The collisions were kind of important because I did have a couple pinch points I had to deal with, and the part motion from moving from place to place. CNC side, I can do the CNC programming, I can do the robot programming, tool and fixture offsets, and all the machine parameters are built into this platform, which was a lot, but it just made kind of a one-stop shop to get the job done. I call this my divide and conquer, and it's kind of representative of what's going on today. No one person can kind of sit down and do everything. You have to have a way to divide up your work, and so this digital platform allowed me to divide the work. So I had a person named Tad, mechanical engineer, who was providing me with essentially the digital twin models of all the stuff he was working on, which is the the work holding, the part management, and the gripping. Jack, he was my CNC guy, so I let him do all the CNC side programming. I did all the robot programming, and then I had to reach out occasionally to a Siemens support. Chris Pollock, he goes by the name Mr. CNC in social media world, and so he was very helpful. All I was able to do is basically send one file as a .dcp file. I'd upload it to box.com, send him an invite, and he would download it. He would see immediately the problem I was having. He can go in there and change machine parameters or change the program, send it back to me, and that was the loop that we had to move this project forward. So what I see now happening in the industry is the IT world has moved to more of a remote support, with subscription-based products. And I think for the same reason, the IT got so complicated, especially when you add security into it, companies could no longer afford to retain a full-time security officer on premise. And so they had to come in and, all the computers they have and the switches they have and the servers they have, all have little interfaces to connect to that support system. And I see the same thing happening with CNC, especially when you add automation into the mix. So we're just in the beginning part of this connectivity and being able to share. System integration, I had to bring in the robot, connect it to the CNC. Luckily, we have our own engineering, so I can deal with any problem that I had, including making changes to the PLC. This was a clearance problem that I spoke of before, which did show up on my digital twin. I just had to make sure that when the real parts came out, they put them back to what we had in the digital twin. And this is a grid plate I used to manage the parts. This was kind of an afterthought. I didn't think about when the parts come off the machine, what's next. But I had to sit down and figure out how to, include inspection as part of, the whole product that I was working on. So we do a first article, kind of old school. And then for the sampling plan, I kind of came up with this. We'll check the first part, we'll check the last part, we'll check the part from each row. And that was good enough for this particular part. Final result, it's kind of what you saw before. Everybody's pretty happy with it. And this is the way the parts are delivered when they're all done. So it's happy to see output from this project. All right, data-driven manufacturing. I think the first thing is least the way we talk to our customers, is, connect up all your machines that you've targeted. Just get some sense of how often you're running. And that's the kind of the first wake-up call. You'll see that there's plenty of opportunity to do a better job. And this is just actually the machine I have here is the mill that I just displayed with the robot. And this is a snapshot of, let me back up one slide. This is last week. So this is what we did last week with this particular machine and the robot. So you can see there's plenty of room for improvement. And also I had to make several, I was there just Tuesday and Thursday, so I can see what's kind of going on with my own eyes. The other time I'm sending text messages or on my cell phone, trying to figure out, why is the machine stopped, what we can do about it to get it going again. This is this week, so you can see it's a lot better. And finally, we're getting some really long run times. There's about 48 parts on the grid plate, and we're doing about 2 parts per hour. So the math is fairly simple to figure out how long your run times are going to be before you run out of parts. What I started doing is kind of envisioning how our particular dashboard is a development dashboard, so we're constantly changing it. So these are the things that I'm proposing that we do next. Next one is downtime. When you back up here, you really don't get much information about what's going on. So I started looking at my camera feeds and then time stamping the camera feed to the air log to what the dashboard should look like or could look like. So I've kind of said, if it's green, I'd like to know what program it's running. So this particular program is called main. And at 11 o'clock, it got this particular alarm. And then I looked at the video feed, and basically he pressed e-stop, and then he pressed reset, and then he went into a kind of a manual mode. So that's how I would interpret the data to, in terms of being able to manage this machine remotely and have some sense of, what's going on. Also notice that even in the MTConnect world, it's all green, but when the machine's waiting for the robot cycle is about 4 minutes, it's still in cycle or executing that program. I know the robot group and the machine group did put in a wait state functionality to try to help this along, but I guess this is an example of why you would need a wait state. But if I was processing that data, I'd like to see this, the 22-minute machine cycle and the 4-minute robot cycle. So you get some kind of uniform pattern and get some sense that everything's working okay. Any questions so far? All right.
Hey, Tom, Jan here. Sorry, looking for the mute button. Your camera feed, do you do any analysis on that, or you just look at it post-event or something?
I look at it in real time, and I do a lot of captures, and basically at some point I'm probably gonna present that to the software group to put an overlays on my camera feed. Let me see if I get it up. Yeah, I have a fair lot of cameras. So this is live. And so you can see, I can see the machine, I can see what operation it's doing. I can look at the grid plate, I can see where we are in terms of the parts. I can't see the CNC screen. I like to see the screen and what the screen's doing. And so I have several views. We had trouble with the chip conveyor, and so I got a camera in the back of the machine. That caused some problems early on. This is the robot view. So yeah, camera and video feeds are, I think, an important part of learning how to at least run equipment remotely, especially if you're the subject matter expert and you want to kind of observe what's going on.
Yeah, I totally agree with you, but it would be really nice if we had some, magic AI ML way to eventually automate all that, right? That when because one of the things also that's extremely important to me is we have a big productivity leak with M0s and M1s. You know
Yeah,
that.
I'm going to get to that. That's one of my problems
Oh,
too.
okay. Sorry. I'm thank you, because you know, the response on an M0, which is necessary in our case, many times the M0 is totally necessary, but sometimes the response is 2 minutes and other times it's 2 days. And,
Right.
you know, that the camera would really help at that point. Anyway,
Yeah.
sorry.
No, exactly. This particular example is showing when simply they didn't put enough coolant in the coolant tank, and then overnight, but the way the machine works, if it doesn't get up the pressure, the machine just sits there and waits. So it was still showing green, but I went in and said, I really would like to see the warning show up and then the warning number. And this is about how long it waited until the pressure got up to start running again. So again, it's the way you present the data. You know, first you have to generate the data, then you have to actually figure out how you're going to present it so it makes some sense to your customer. And this is the optional stop. So this is what John just spoke of, because I certainly saw this as well. Is again, I'd like to see the optional stops kind of show up in a different color, so I can actually see the pattern and actually see where the operator intervened and basically enable. There's 2 steps. You have to enable optional steps, and then they basically have to respond to it if it's enabled. Is that kind of what you had in mind, John?
Yes. I'm looking for the unmute button again. Yes. Yeah. And then also, you know, kind of the eventually, you know, trying to figure out, you know, what the reasons were, because you're showing them pretty consistent. I find that in our case, they're very inconsistent. The op stops are on, and then they, you know, so the M1s are the machine stops at M1s. You know, like I said, sometimes it's 2 minutes, sometimes it's 2 days. The machine is just waiting, and maybe the camera, because sometimes it's real, right? It's or link it to lunchtime. You know, the all these other you know, known reasons why sometimes an op stop can be longer, but sometimes it's just, you know, you really want to know what the operator was doing.
Yeah, I spoke to several of your guys, the Fort Worth plant and then Skunk Works plant, about this as well. So getting
Okay.
your team on board.
Yeah.
All right. And other thing we talk about with our customers is basically they just need a simple way to figure out what to do with their time. There's a company in San Diego I visited. They have about 80 machines scattered across 3 buildings. They're both getting up there in age, and they just simply told me they're getting tired of getting up in the morning and going around talking to operators to figure out what to do. So it's like basically kind of lobby for anybody who's kind of getting into data is to start with a simple dashboard, because you'll get a lot of value out of that. The robot group, I knew this was kind of coming, so this is one of the issues that I brought up to support work cell controllers in our own robot group, because I didn't see there was much out there. The only person I think who's kind of working on this was Predator Software with Mike Rogers, who is part of the robot group, and now he's running the parts and process group. So we're on this particular track to try to create the support for these things for as these products roll out, we'll have MTConnect support for them. For me, we've got 5 or 6 machines currently running in this overnight. Sometimes they run just a few hours after working hours, and in my case, it's running you know, all night and through the next day. So I kind of envision mini cells and being able to look with my cell phone and just take little quick snippets to see how things are going on. So I kind of basically had the identification as a big subject, the status information is a big subject, The part information is a big subject, because once you get past your cells running, you really want to know if your parts are good and they're flowing through as expected. Things like the batch size, the process inspection information. And so that's where the robot group kind of expanded out to this cross-working group subject for the parts and process and also metrology. And that's kind of where we're at today, is getting those guys to help us with some of the definitions and examples of how we might implement this. Will created this example XML file, so this is kind of where we're at with cell controllers, which is validating this, and so this is an active subject we're kind of working on. Will, do you want to chime in on this if you're on? I don't know if he's back.
He's not on. He's got another set of meetings today.
Okay. Metrology group guidance. We're still trying to figure out how to get information into MTConnect. So this is just an example of what we, most people have as a first article document that they just hand fill out. And so the question is how do we get this data entry converted into a QIF format? And Larry's been very helpful with coming to some of our meetings, and we're in the process of trying to figure this out. But I guess the good news now is I have real data. We have data coming from the machine. The machine does probing, so there's a Renishaw probe on it that does do some measurement for us. And then we have just people handwriting data into a piece of paper. Parts and process guidance. So this is Mike Rogers' area. So we have the parts that are in the machine. I got the parts on the grid plate. I got parts on the table, and I got parts in boxes. So a given, I'm sitting at home and I just want to say, hey, where are we at with that work order? And the data is coming from all different places. So again, we're looking for the parts and process group for their guidance on how we should approach this. This is a probing data text file that generates. So when it does some measurement, it generates this file. So now the problem is either I can read the file or I have to go out and find the data that's stuck in some variable inside the control and get it out of there and get it into a QIF format. So again, we're looking for the metrology group's guidance to figure out how to do that. For the most part, the parts, you can see 2/10, 3/10, 2/10. So the parts are repeating pretty good.
You know that Renishaw already demoed that at MASAC, the MASAC event in 2019, right?
Yeah, I saw that, but I didn't pay much attention at that time.
Yeah, but it's the technology exists, so
I have a reason.
okay, yeah. No, because that is indeed, now that was a demo. Now that you have indeed data, let's do it on some real stuff. I'd love to see that. Yeah, so let me know how I can support.
Okay.
Hey Tom, have you talked to Matt Powley about this?
No, I haven't. But what was funny though, at the last meeting at GE, Dave Morley noticed that he was using the same digital platform software that I had, and Dave came over and says, where did Matt? So we went over and talked to Matt about his digital twin work, and then plus my digital twin work.
Yeah, Matt's in the UK, but so I think he's asleep now, but he was on the call or with his kids or something, but he was on the call earlier. I'll make sure he gets the recording of this and put you guys in touch again.
This is actually the first time we did a 24-hour run. So I just used my video feed to kind of take a snapshot of the grid plate at 7:32 on Tuesday a.m. And then the following day at 7:36 a.m. on Wednesday, an average run throughout the whole previous day and the whole night. And so this looks like it did mostly all the parts except for 2 on the grid plate. So just kind of a snapshot of production. So I guess the point here is that grid plate's pretty important for the parts and process group, because that's the accountability for that production. Benefits of digital twins is, the offline and programming environment is exact duplicate of the control of the shop floor. So I'm not talking about like a CAD CAM system that's just generating a G code file and sending it to that. I'm talking about having, basically a software copy running in a computer. It's exactly the same software copy of the machine tool running in the shop. That brings over all the fixture offsets, all the tool offsets, every single parameter that the user has access to can now be, managed offline. And the other thing is basically you're working on the next setup while the machine is making parts. So you can design and do your verifications. And for a lot of our customers, this is a big one. You own the process. Today, a lot of the work is divided among several people. When those people leave or they change positions, you're stuck with trying to figure out what they did. So if you have a digital twin, you own that process, and that's a big justification for a lot of our customers. And kind of ongoing improvements. Certainly, I capture what's kind of going on, and when I see things, it's like, wow, that was dumb. Let's try this another way. So I can do all that offline and kind of work out the detail. And then when there's downtime, being able to switch over. The last one is also a good one for our customers as well. As you mentioned, I did a lot of this work before anything existed, so I can come up with a pretty good quote of the cycle time and the robot time and some of the handling time without investing a lot of money. So you're able to, do better with your quoting. So since I have some time, I have some fill in here. I just want to talk about problems. Okay, in that digital world, you're living in this idealistic kind of bubble, but I got to live in both. So one of the first problems I had is this thing generates a lot of chips. So we went through several different design changes to, I guess, step one was make the chips smaller. So we changed to a different kind of tool. By making the chips smaller, the washdown nozzles were able to push the chips into the chip conveyor. So that took a few days of scratching our head and figuring that out. So I guess with this Cobb style cutter, basically eats the problem. Parts everywhere. I didn't, for the scope of my project, I didn't really look at what happens after the part comes out of the machine. So they just started stacking up these parts. These are cosmetic parts. We don't want to get them scratched or damaged. And so I had to come in and basically do another digital twin of part handling for after the fact. And so I basically created these 3 benches, a bench to queue up the parts, a bench just for inspection, a bench for packaging, and then a rollaway for the raw stock. And now everything comes out nice and clean. Chip buildup underneath the part. So you saw the robot kind of do some extra air blasting. So the goal there is to get these chips out and basically don't have any chips after each cycle, so there's no possibility to build up. So that took a little while to address. Chip buildup inside the bore. This is just simple troubleshooting, so we were able to resolve this by just rotating the part 180 degrees, so the bores were facing away from the cutter. So I had to go in and change the program to be able to do that, and change the robot to be able to do that as well. Part coming out of the vise. Looks kind of beat up, doesn't it? So actually my video feed caught this, and it was a kind of a semi-dangerous situation. This part came out of the vise, started wrapping around the tool, so it's just bouncing around in the tool, made terrible sound. Eventually the cutter broke and flew out and hit the sheet metal. Now there's a big dent in the sheet metal where the part hit. So I went back and looked at the video feed and also looked at a few error messages. I noticed that the robot caught a low air pressure set point, but the CNC did not. So when the guy did the PLC, he didn't carry that alarm back to the CNC. So we kind of had to learn that. Similar, a part came out of another vise. This is where the helical cut of the tool was exerting Z force, and something we didn't have enough clamping force. So this part came flying out of the vise. So what we had to do is just compromise on our feeds and speeds to stay within the limits of the clamping system. If I have to do over again, I'm using air vices, and they have about 2,100 pounds of clamping force, which is really on the low side. So I'd have to move to a hydraulic system or a different type of clamping system to get aggressive with some of these cuts. Broken tools. That's one of the things I want to do is work on tool management. Currently, we're kind of what I call winging it. And sometimes winging it means that you listen for a different sound when the machine starts to make kind of funny sound or the current goes up on the loads, you know your tools are wearing out. So with our control, it does have a tool management system, but that manual is over 500 pages long, and I just haven't had time to go through and read it and implement it. But it's one of my things that I can do in the digital twin environment. When I've kind of figured out, then I can bring it over to the real CNC. Okay, and I think that's the end of that I had. I'll go back to questions. So that's the whole process, cradle to grave, so to speak. Questions, anyone?
Yeah, Tom, going pretty far back to the beginning, like what for this particular part in the automation you applied to it, what's the package of documentation, both in the planning phase and in the execution and maintenance phase? Like what you talk about building consensus, what do you actually take into these people inside your company to try and make sure they understand what you're talking about, sometimes before the stuff exists and sometimes after the stuff is already in place?
The easiest way to talk to people is with these dashboards. Actually, let me bring up the real dashboard. All right, this is a real dashboard of a bunch of machines that I have. I think it's probably like 40 machines. And when I want to talk to the first thing, it's like, well, what's going on here? You can see there's still a fair amount of red. It's about 10:30 here in the West Coast. So this is kind of right at 10:30. And so you want to talk to them about just utilization. And you can see there's just all different kinds of patterns. And so we put filters in to get them to focus. This is the machine. This is my machine with a robot on it. So it's still running pretty nicely. And so I can talk something about, making parts. And I've done several talks on just connecting a machine shop, which is a monumental task for a lot of our customers. They may have, 10 machines, 20 machines, or 30 machines, and just to get them connected is a big job for them, and plus a lot of money. And that's, let's say, an industry just, that needs a lot of support. We've gone through the same thing. We try to connect the machines. We try to go through the IT department. The IT department kind of does it their way, so to speak. And I had to create what I call a Track Connect workstation, which is basically a separate network controller. So it manages all the VLANs. It manages all the security, in parallel to our IT department, which is actually managed remotely. And in that box, what I did put is it's a rack mount box, but there's a space for a second firewall. So that second firewall is the IT department's firewall. So they give me kind of a range of things I can do or can't do. And then as I need data, because these machines don't need to be connected to the internet and be able to browse everything on there. So I just need kind of one IP address, just one port. And so we just negotiate that on an exception basis. In other words, they block us, but then I go in and negotiate exceptions on a case-by-case basis to have access. Does that make sense? I know, Jan, you probably deal with this quite a bit. So that's the first step. It's connecting your machines and simply getting a dashboard so you can see, how to spend your time.
Yeah. You're asking whether we deal with it a lot? Yeah, we do.
So I'm just saying, you have your IT people, and you have the manufacturing people, and how do you deal with conflict when they
Yeah,
want
that's
to.
why. Yeah, that's why we developed this very elaborate gateway that allows us all kind of functionality. But yeah, we spent years trying to fix this very specific problem, and even today we still don't allow anybody from the outside access to our machines. It's just the
Yeah.
the security risk is just too big at this point, or not well understood, and therefore so outside access to our machines is just impossible.
Right.
But even internally, now internally, it's a lot easier to get access to the machines, by the way, because of this gateway. So internally, the project of access to machinery is much better now than it was before we had the gateway.
Sure. And Russ, the other thing is, we think that no one will buy a machine unless it has some level of communication option available for it. I mean, today, who would buy a machine and basically you just get RS-232? So we're looking for, at least for our products, to have plenty of support, whether it be OPC-UA or MTConnect. Those are the two primary ones. And then the other thing that's kind of heading down our path is the be able to connect to different kinds of devices, like a CNC to a quarter measure machine. So that's what kind of brought up the read specification again, because I think a lot of customers do want to connect, create little cells, but it's a huge job right now to connect a robot to a CNC and then connect that to a coordinate measurement machine, and then have some kind of software be able to orchestrate, running the job. So I'm kind of headed in that path right now because that's kind of what I want to do. Anybody else have connectivity issues with machines and other devices? All right. Any other questions? I know there's a lot here. A lot of you guys work in just the software side, but as Russ said, I get the luxury of crossing over and kind of deal with all these subjects with the intent to sell products and make money from a company. Okay, Russ, I think that's all I've got.